Okay, solving this shouldn't be too bad. Sorry if I over-egged the writing it slightly. So we have differential equation. We can't just integrate with respect to t because of that x. You can't separate the variables because of the 160. So this is one where you have to use an integrating factor. And that gives you 160. And then the integrating factor, so we're going to be integrating with respect to t, is e to the integral of 3 over 100 plus t with respect to t, which is e to the 3 ln of 100 plus t, and then you could bring up the power, and that gives you 100 plus t cubed. So multiplying through, plus t squared x is equal to 160, 100 plus t cubes. That takes us to there. And then this bit here, sorry, I ended up with 2 x's there, didn't mean that. So this bit here is what you get when you differentiate with respect to t, 100 plus t cubed x, and that's equal to the right hand side. So this should start just to feel, yeah, you should be feeling quite comfortable with these by now, hopefully. Integrating both sides with respect to t. And then the right hand side, I need to add 1 to the power, divide by the new power. And then times by 1 over the coefficient of t, but that is just 1, so don't need to worry about that for this one, plus c, and then we're told that when t is 0, x is 0 in the question. That gives you that 0 is equal to 4 times 10 to the power of 9, plugging into that, plus c, and so c is equal to minus 4 times 10 to the power 9, and so x lots of 100 plus t cubed. Don't forget to evaluate your c. Keep nagging you about that. Plus t to the power 4 minus 4 times 10 to the power 9. And we want x after 6 hours. So when t is equal to 6, then it's just a question of plugging in. I kind of know you're all right with this bit, so I'm rushing it slightly. 106 cubed equals 40 lots of 106 to the power of 4 minus 4 times 10 to the 9, and from there x comes out as being 882 grams. So that's the amount of copper sulfate after 6 hours, I believe. I've lost the question now. And then part C was just asking you how you could maybe model it slightly better, and it's really good with these sort of questions just to think about, well, what modelling assumptions have been made. And so the main one here is that the copper sulfate immediately disperses throughout the tank. That isn't going to happen in real life, so it's quite often useful just to pop back to the question, what assumption has been made that isn't realistic? There'll be one somewhere. So I would say, that's kind of the main thing you could do just to make the model more realistic. Take into account that the copper sulfate won't disperse immediately. But obviously that will make the question a lot harder. Through the tank. Sorry, I've done lots of smudging there. So take into account that the copper sulfate won't disperse immediately through the tank. But this, you know, this is kind of, you've done a lot of work on this bit here. The main thing with that one, I think, was actually writing that differential equation. But it's a show that, so, you know. Right, leave it there.